Hi all, today we are going to discuss about introduction of operations research.
What is operations research?
The British or Europeans refer to operational research, the Americans to operations research, but both are often shortened to just OR, which is the term we will use. Another term which is used for this field is management science, MS. The Americans sometimes combine the terms OR and MS together and say OR or MS or ORMS. Yet other terms sometimes used are industrial engineering, IE, and decision science, DS. In recent years there has been a move towards a standardization upon a single term for the field, namely the term OR. Operation research is a relatively new discipline. The contents and the boundaries of the OR are not yet fixed. Therefore, to give a formal definition of the term operations research is a difficult task. The OR starts when mathematical and quantitative techniques are used to substantiate the decision being taken. The main activity of a manager is the decision making. In our daily life we make the decisions even without noticing them. The decisions are taken simply by common sense, judgment and expertise without using any mathematical or any other model in simple situations. But the decisions we are concerned here with are complex and heavily responsible. Examples are public transportation network planning in a city having its own layout of factories, residential blocks, or finding the appropriate product mix when there exists a large number of products with different profit contributions and production requirement, etc. Operations research tools are not from any one discipline. Operations research takes tools from different disciplines such as mathematics, statistics, economics, psychology, engineering, etc. and combines these tools to make a new set of knowledge for decision making. Today, OR became a professional discipline which deals with the application of scientific methods for making decisions, and especially to the allocation of scarce resources. The main purpose of OR is to provide a rational basis for decisions making in the absence of complete information, because the systems composed of human, machine, and procedures do not have complete information.
OR specialists are involved in three classical aspects of science. They are as
I. Determining the system's behavior. A. Analyzing the system's behavior by developing appropriate models. C. Predict the future behavior using these models.
Now we discuss about stages of development of operations research.
The stages of development of OR are also known as phases in process of OR, which has 6 important steps. These 6 steps are arranged in the following order. Step A. Observe the problem environment. Step 2. Analyze and define the problem. Step 3. Develop a model. Step V. Select appropriate data input. Step V. Provide a solution and test its reasonableness. Step 6. Implement the solution.
Now we discuss about the definitions of operations research.
It is the application of scientific methods, techniques and tools to problems involving the operations of a system, so as to provide those in the control of the system with optimum solutions to the problems. Another definitions of OR are:
Operation research is a tool for taking decisions which searches for the optimum results in parity with the overall objectives and constraints of the organization. OR is a scientific method of providing executive department with a quantitative basis of decisions regarding the operations under their control. OR is a scientific approach to problem solving for management. OR is an aid for executive in making his decisions by providing him with the needed quantitative information based on the scientific method of analysis. Next area of discussion is OR tools and techniques.
Linear programming. This is a constraint optimization technique, which optimizes some criterion within some constraints. In linear programming, the objective function, profit, loss or return on investment, and constraints are linear. There are different methods available to solve linear programming. Game theory. This is used for making decisions under conflicting situations where there are one or more players/opponents. In this, the motive of the players are dichotomized. The success of one player tends to at the cost of other players, and hence they are in conflict. Decision theory. Decision theory is concerned with making decisions under conditions of complete certainty about the future outcomes, and under conditions such that we can make some probability about what will happen in future.
Queuing theory. This is used in situations where the queue is formed, for example customers waiting for service, aircrafts waiting for landing, jobs waiting for processing in the computer system, etc. The objective here is minimizing the cost of waiting without increasing the cost of servicing. Inventory models. Inventory model make decisions that minimize total inventory cost. This model successfully reduces the total cost of purchasing, carrying, and out-of-stock inventory. Simulation. Simulation is a procedure that studies a problem by creating a model of the process involved in that problem and then through a series of organized trials and error solutions attempt to determine the best solution. Sometimes this is a difficult/time-consuming procedure. Simulation is used when actual experimentation is not feasible or solution of model is not possible. Nonlinear programming. This is used when the objective function and the constraints are not linear in nature. Linear relationship may be applied to approximate nonlinear constraints, but limited to some range, because approximation becomes poorer as the range is extended. Thus, the nonlinear programming is used to determine the approximation in which a solution lies, and then the solution is obtained using linear methods. Dynamic programming. Dynamic programming is a method of analyzing multi-stage decision processes. In this, each elementary decision depends on those preceding decisions and as well as external factors. Integer programming. If one or more variables of the problem take integral values only, then dynamic programming method is used. For example, number or motor in an organization, number of passenger in an aircraft, number of generators in a power generating plant, etc. Markov process. Markov process permits to predict changes over time. Information about the behavior of a system is known. This is used in decision-making in situations where the various states are defined. The probability from one state to another state is known and depends on the current state and is independent of how we have arrived at that particular state.
Network scheduling. This technique is used extensively to plan, schedule, and monitor large projects, for example computer system installation, R&D design, construction, maintenance, etc. The aim of this technique is minimize trouble spots, such as delays, interruption, production bottlenecks, etc., by identifying the critical factors. The different activities and their relationships of the entire project are represented diagrammatically with the help of networks and arrows, which is used for identifying critical activities and path. There are two main types of technique in network scheduling. They are Program Evaluation and Review Technique. PERT is used when activities time is not known accurately / only probabilistic estimates of time is available. Critical Path Method (CPM) is used when activities time is known accurately. Information Theory. This analytical process is transferred from the electrical communication field to OR field. The objective of this theory is to evaluate the effectiveness of flow of information with a given system. This is used mainly in communication networks, but also has indirect influence in simulating the examination of business organizational structure with the view of enhancing flow of information.
Now we discuss about the limitations of operations research.
Operations research has a number of applications. Similarly, it also has certain limitations. These limitations are mostly related to the model building and money and time factors problems involved in its application. Some of them are discussed here. Distance between OR specialist and manager. Operations researcher's job needs a mathematician or statistician who might not be aware of the business problems. Similarly, a manager is unable to understand the complex nature of operations research. Thus there is a big gap between the two personnel. Magnitude of calculations. The aim of the OR is to find out optimal solution taking into consideration all the factors. In this modern world, these factors are enormous, and expressing them in quantitative model and establishing relationships among these require voluminous calculations, which can be handled only by machines. 3. Money and time costs. The basic data are subjected to frequent changes. Incorporating these changes into operations research models is very expensive. However, a fairly good solution at present may be more desirable than a perfect operations research solution available in future or after some time. IV. Non-quantifiable factors. When all the factors related to a problem can be quantifiable, only then operations research prove it a solution, otherwise not. The non-quantifiable factors are not incorporated in OR models. Importantly, OR models do not take into account emotional factors or qualitative factors. V. Implementation. Once the decision has been taken, it should be implemented. The implementation of decisions is a delicate task. This task must take into account the complexities of human relations and behavior, and in sometimes only the psychological factors.
Thank you all for watching our class.
Thank you.